Hey, this is our first section on solving quadratics. This section has got lots of stuff in it, so we'll probably spend some time on this one section. I think it's 1.3 or 1.4. But anyways, we're going to start off with something that we already know how to do, which is factor. So we're going to use that chapter P information that we should have be familiar with, and we're going to factor, but this time we're going to factor to solve a quadratic, and we're going to use that solving to locate our x-intercepts. So just like any polynomial, you can write it in standard form, which is highest degree to lowest degree in terms. Since quadratic has three terms, the highest power would be the squared, which makes it a quadratic, then the linear, the bx, and then plus c, and we're going to be setting them equal to 0. And when you set a function or an equation equal to 0, what I'm saying is I want to know what value of x when my output is 0. So if we think about, so what value of x, so what value of my input is when my output is 0. And if you remember, input comma output, right? X comma y. So I want to know what is the value of my input when my output isn't a question mark, like I don't know what my x is, but I'm going to specifically say the output is going to equal 0. Okay, that's an important part, right? Because an equation has two variables, an x and a y. I'm going to force my equation to have one of the variables to be known. I'm going to force my y to equal 0, and then I'm going to solve, and I'm going to ask the question, what value of x makes that output 0? And when I do that, and I find a value of x, let's say 7, and I know I've held my output to 0, what I'm finding is an x-intercept. 7 comma 0 is on the x-axis. So that's what we're going to be doing today. So the first thing that's important is when you're doing these is you've got to set your function equal to 0. And it's got to be in standard form. So first off, I have my 2x squared plus 9x plus 3 equals to, plus 7 equals to 3. I need it to equal 0. So I'm going to subtract 3 over, and I get 2x squared plus 9x plus 4 is equal to 0. So now my output is equal to 0. I'm ready to factor. Before I factor, I want to make sure there's no GCF. There isn't. So what I'm going to do is I'm going to factor. This isn't one of the easier ones because I got a 2x squared, but we're going to handle this one. It's not too bad. And what are factors of 4 that make? Want my middles to add up to 9. So, and I need my last step, multiply to get 4. So I'm going to do 4 because 2x times 4 is 8x. That's pretty close to 9. And then I'm left with 1. It has to be 1 because these have to multiply to get 4, right? And so that gets me 1 times x is 1x, and those together get me 9. So I found my two factors, 2x plus 1 times x plus 4, and those are equal to 0. Now I want to find what x value can I plug in for x that will my output will be 0. Well, I have two options here because if you look at these two factors, I have the 0 product property. No matter what, if I plug an x into this one and it causes this term to become 0, then no matter what happens to this other one, the x plus 4, it's going to become 0 because this 0 times whatever that number is, will matter, is going to be 0, and vice versa. So there's two values here that it's going to satisfy. So I'm going to take 2x plus 1, and I'm going to say, when would this possibly be 0? What value would cause that factor to equal 0? And the answer is negative a half. I'm going to do the same thing here, and I get -4. And remember, these are the inputs that I plug into x, where my output is going to be 0, which is an x-intercept. These are quadratic. They're U-shaped. If you plug this into Desmos and you went to -0.5 and -4, you would see this U-shaped function going through the x-axis at those two values. Okay, so that's what we're finding. We're solving to find x-intercepts. Okay, 2. Factor. Well, I have a binomial. The only way that I know to factor a binomial is difference of squares or different cubes. Neither one of those are true, so I'm going to pull out my GCF of 3x. X minus 1 is 0. Now that I have them into their linear factors, I can split those up, solve them for 0. Why would I solve this for 0? Because if this thing becomes 0, then it's going to multiply by the x minus 1, and that will become 0. So it's easy to see that if x was 0, this 3x would become, the whole thing would become 0. So like distributing a 0 into that parentheses would be a 0. Now if I put a 0 in here, it would give me a -1, but it doesn't matter. This is 0. 0 times -1 is 0. That's what I'm after. Sometimes this one gives us a little trick. Just want to make sure. And I get 1. So again, these aren't random x values. These are x values that will produce an output of 0 to my function. So when I plug in 1, I'm going to output 0. And together, those make x-intercepts. Again, if I graph this one, it's the origin. This one is 1. I'm going to have this U-shaped function have 2 x-intercepts, one through the origin and one through +1. Okay, next one. Now notice when I factor, my quadratic term needs to be positive. That's just going to make life easier. And since it's over here positive, I don't want to subtract the minus 2x squared over to the right side. I'm going to want to bring these two terms over to the left side. So to do that, I just do the mental math. It's a positive 19x, so I subtract 19 from both sides. That will cancel that out. Got a positive 33 on the right side. I'm going to subtract 33 from both sides, and then I'm going to be left with a 0. Now I'm ready to factor. Have a 2x and an x. Negative 19 is quite a big number, so I'm going to need a negative and a positive. I'm going to put 11. That gives me negative 22x. My next one's going to give me a positive, which will cut this negative down a little bit. Gives me a positive 3x, and together those add to get me negative 19, so those are the correct two factors. Okay, the next thing I want to know is what causes this factor to be 0, because as soon as it goes to 0, that's going to cause this other factor to multiply no matter what it is, it becomes 0, and that's what I'm after. So I'm going to set it equal to 0. I'm going to do over here, 2x3 is equal to 0. Get pretty good at these. You can just do mental math. I'll work. X equals negative 3 halves. Do not write that as a decimal. Do not write it as an improper fraction. Okay. My next one is x minus 11 equals 0. I mean a mixed number. We always write it as an improper. It's late. I'm tired. Late for me anyways. We're doing work. Okay. So x equals 11. Again, these are my x-intercepts, 11, 0, and negative 3 over 2. Find an x-intercepts. It's important. Okay. Number 4. Next thing I'm going to do is, well, first thing I'm going to do is say I don't like fractions either, not especially when factoring. I know you can all agree. So we already talked on the last INB how we can get rid of fractions. What are we going to do? We're going to multiply by that denominator, or everything that will cancel out this denominator. Only have one fraction, so that's pretty easy. What makes 8 go away is multiplying the top by 8. Multiply the top by 8, and I get x squared. But unfortunately, we're going to have to multiply everything by 8. And so I get negative 8x, and I get what? 16 times 8, 48, or 128. And now I've got to find two numbers that multiply to get negative 128 that are going to subtract to get me negative 8. And I'm like, boom, right here, right? I just did that math, 16 times 8. That was nice. So x minus 16 times x plus 8. These are easy too when it's a nice one coefficient. And I have an x-intercept of 16 and one of negative 8. It's really important to realize I'm setting my output to 0, and I'm using that to determine what my x's are. So I'm finding an x-intercept by setting my y equal to 0. Okay, it's not magic. I'm not magically setting it to 0 for any other reason. Okay, next one is just another method. It's called the square root method. And we do this when we have one visible variable. Okay, and so notice all up here, I had two different x terms. I had a square and a linear. I can't combine them. So how do I solve when there's two terms? Well, you have to factor when there's two x terms like that that won't combine. Well, how do I do it when I just have one variable? That's pretty easy. We can always solve for 1x. But let's stop here. Now, we should all know that the inverse of a square is square rooting, and inverses cancel each other. So I know I'm going to square root this x squared, right? Because we all know the square root of x squared is x. That's going to get me x by itself, right? However, it's important to look at this problem and say, how many numbers can I plug in there that will output this 3? And it's not going to be a pretty number, but there's going to be two, the negative one and the positive one, right? So if I had x squared is equal to 9, this would be 3 and negative 3, right? Both of those, because the square is going to change the negative back to a positive. So we don't have to think about that every time. However, what you don't want to make is a careless mistake and forget that there are two solutions here, positive and the negative, right? So if I square the square root of 3, then guess what? Square root of 3 times square root of 3 is 3. If I square negative square root of 3, negative square root of 3 times negative square root of 3 is positive 3. Okay? So don't forget the plus and minus. That's a common mistake. So I'm going to write these. These are my x-intercepts, right? They are. Boom. Okay? You might say, wait a second, you didn't solve this. You didn't set it equal to 0. Well, if we want to be technical, you don't see a y there. So what must have happened to the y? It was set equal to 0. That was probably back here at the stage. It was set equal to 0. The visible y being gone must have mean it was set equal to 0. Okay, next one. I'm going to divide, not distribute. Square to get rid of square root to get rid of the square. X minus 3 equals yes plus or minus the square root of 7. And then I'm going to add 3. So how do we split this up into the two solutions? X is equal to 3 plus the square root of 7. Boop, boop, boop. There we go. And if I wanted to write comma 0, I could, but I don't feel like it. Okay. Number 3. Boom. I'm ready to square root right away. You know what I see when I see square root of 44? The same thing that I see that you see when you see 4/8. You go, wait a second, that doesn't happen, right? Same way Mr. Cavendish sees this is 2 plus or minus 2 square root of 11, right? See that square root of 4 is in 44. Okay, and now I'm just going to solve. I'm going to subtract my 7x over, and I'm going to divide by 4. What formula does this look like? Opposite b plus or minus the square root, right? All divided by 2a. That's exactly right. Okay, I'm just going to leave it like this. No, I'm not. You should be able to split these up, right? Because if I ask you to graph these, which I could, like these are the x-intercepts, they're irrational. I can definitely estimate these values and put them on a graph. So you're going to have to be able to split them up like this and put them in a calculator and get a decimal approximation. Okay, next one, 4. Here's that extra spicy one everybody was saying that they need to see on their INB. That's about as hard as they get. You're going to square root both sides to get rid of the square. And this cancels the square. Get x plus 5 is equal to plus or minus x plus 4. Now let's think about that, because you might say, well, why didn't you plus or minus both sides? Well, look up here. When I squared the left side to get x by the self, I didn't plus or minus this. I just plus or minus the one on the right. So I'm going to stay in the same realm as that. Okay? So I get x plus 5 is equal to what? Positive version. So x plus 4, and then x plus 5. And then our famous thing to forget is x plus 4. Right? Distribute, distribute, distribute. Okay. Alrighty. Now I'm going to solve the two equations. Uh-oh. What happens when my variables cancel out and I'm only left with my constants? Well, I make a decision. Is that a true statement or a false? Well, it's false, so this is no solution. If it was 5 equals 5, then that means any number would work. Now, that just means this isn't a solution, so this is no solution. Doesn't mean a solution doesn't exist over here. And boom, get a solution. Okay. I'll have our next video up tomorrow. Sorry that this one was late.